Hello everyone, this video is to show you how to implement the ZigBee transceiver using the BeeClick from MikroElektronika. This is the BeeClick, which is the ZigBee transceiver module from MikroElektronika, and I'm going to use PIC 18F45K22. I'm going to use the same example that is available on LibStock, and the same example and schematics that is available on EasyPIC version 7. But I'm only going to use it on breadboards because I can't afford an EasyPIC version 7. So I'm going to tell you how to connect the BeeClick to the PIC microcontroller pin by pin from the BeeClick. First, we have the first pin. I'm going to assume that is an IC, so the numbering is going from here all the way from here. Okay, pin number 1 is called Wake. This is connected to RC7 to the microcontroller, which is pin 26. The second pin is called RST, which is connected to RE1, which is pin 9 from the PIC microcontroller. The third pin is called CS and is connected to RE0, which is pin number 8 from the PIC microcontroller. The fourth pin, which is called SCK, it's connected to RC3, which is pin 18, which is this one, I think, the orange one. Okay, then we have the fifth pin, which is called SDO. It is connected to RC4, which is pin 23. It should be one of those here. Now it's the sixth pin, which is SDI. It's connected to RC5, which is pin 24. Again, this one here. Now the eighth pin and the ninth pin, this one and this one, should be connected to the ground of the circuit. And then the last pin is the INT pin, which is number 15. It is connected to RB0, which is pin number 33 on the PIC microcontroller. We have the seventh pin, which is the 3.3 volt. It should be connected to our 3.3 power supply, which is connected here in my circuit. And of course, as I already said, pin number 8 and pin number 9 should be connected to the ground of the circuit. This circuit uses 3.3 volts as a power supply, which means that this will operate on a 3.3 voltage supply and this will operate on 3.3 voltage power supply. Okay, now what's about the other pins of the PIC microcontroller? Which pins did I use? Pin number 1 is Microcontroller Reset. By default, it is connected to the 3.3 volt through a 22 kilo ohm resistor. But if I clicked this switch, then it will be connected to the ground and the PIC microcontroller will reset. An 8 megahertz crystal, this is the one, an 8 megahertz crystal is connected across RA6 and RA7, which are pins 13 and 14. Okay, and these are two resistors with a value of 22 picofarad connected to each one of these pins and to the ground of the circuit. Now, there are 8 light-emitting diodes over here. They are connected to the ground, their cathodes are connected to the ground, and their anodes is connected to a protecting resistor. I think the values are 390 ohms. These are connected to port D, the output of the transmitter, and the receiver will be displayed on port D. Okay, the PIC microcontroller has 2 pins for power supply and 2 pins for ground. I use the ones that are on the left. The power supply is taken from pin 32 and the ground is taken from pin 31. There are other pins for the power supply and the ground here, but I didn't use them. Okay, now this is the receiver circuit, as you can see it. The transmitter circuit is actually exactly the same. Now, let me bring up the camera. This is the receiver circuit, and over there is the transmitter circuit. As I said, I didn't program this project by myself. The source code is available at LibStock. So, what did they do in LibStock? They actually made the transmitter made a counter that counts from 0 to 255 and then repeat the count. Allow me to show you by connecting the ground. As you can see, the power lid on the BeeClick is turned on, which indicates that it's working, and the counter has already started. Let me reset it to make you see it from the beginning. Number 1, 2, 3, 4, 5, and so on. Let me now turn off by removing the ground. Let's get back to the receiver circuit. Okay, this is the receiver circuit. When I put the power supply, the ground of the power supply, the BeeClick is working, but no LED is turning on. You should know that the transmitter circuit and the receiver circuit are identical, so they are exactly the same. As you can see, the receiver is not doing anything at the moment because it is not receiving any data. Let's go back to the transmitter circuit. Now, as I put the power supply back on, the receiver circuit will do exactly what the transmitter circuit is doing. You see the LEDs here? You can see exactly over there, but a bit far. Let me show you. They're doing exactly as the LEDs on the transmitter circuit is doing. Let me put them near each other to make you see it better. Now there you go. Both of them. If you have any questions, please leave a comment. Thank you very much for watching.